Hello and welcome back. So this video is for class 9th and we will continue with the chapter Gravitation. Now previously we have seen the concept of the Newton's law of gravitation and we saw the concept of free fall. Today we are going to see acceleration due to gravity and we will find a formula to calculate g. Okay, so let's begin. So we have seen that a free fall means when an object falls only under the force of gravity. Okay, that we call as free fall. For example, if I take this chalk and I let go, when the chalk falls, this motion of the chalk is a free fall. So there was a doubt asked that if there is any opposite to free fall. Okay, now as such there is no opposite, but can there be a motion which is not called as free fall? Yes. Okay, for example, if I take this chalk and I am throwing it on the ground, right? So what happens? There is my force and the force of gravity. So two forces are there on this chalk when it is going down. In that case, this will not be a free fall. Making sense? So if we are throwing an object to the ground where our hand is applying the force, in that case that will not be a free fall. But if we just let go, it is going down only and only because of gravitation, right? So that is called as a free fall. Another doubt asked was about why there is the force of gravitation in the universe. Now that is a concept, okay, that is very much higher and it is not for 9th class. A very short answer I will give you. Gravitation exists because of the bending of space and time. Okay, but again, as I said, when you come to 12th class maybe, then we can discuss it, but at this stage it will not be very easy for you to understand. Okay, so mostly don't think about that thing about why gravitation exists. Right now you should be thinking about how to calculate the force of gravitation. Okay, but anyways, so as I said, today we will talk about how to calculate acceleration due to gravity. Okay, so now imagine this is our earth, okay, and capital R is the radius of the earth. Fine. There is an object, okay, let us say of mass small m, that is placed on the earth. Okay, this could be any object. Okay, it could be you and me, it could be any stone, it can be any object that is placed on the earth. Now this object is under the earth's gravitational force. Okay, and we know by Newton's law of gravitation we can calculate that force, right? So how will we calculate that force? We will say that force will be equal to, first we take capital G, which is the universal constant, then product of the masses. Let us say the mass of the earth is capital M and the mass of the object is small m. So what will be product of mass? Capital M into small m. So F will be equal to capital G, capital M, small m divided by square of the distance. How much will be the distance between the object and the earth? The distance will be equal to radius of the earth. Remember, even when object is on the earth, the distance is not zero. Why? The distance is calculated from center to center. So we will be calculating the distance from the center of the earth, which is capital R, that is radius of the earth. So we will get this formula as F equal to G capital M into small m divided by capital R square. Let us call this as our first equation. Correct? So this force, this F is giving the gravitational force on the object that is placed on the earth. Fine till here? Now, but we also know from Newton's second law of motion, force can be written as mass into acceleration. Correct? So for this object small m, we can write F is equal to mass into acceleration. But when you are on the earth, acceleration is denoted by small g. Correct? That is acceleration due to gravity. So instead of writing F is equal to ma, we can simply write F is equal to mg. Okay, here g is the acceleration due to gravity. This let us call as equation number 2. Both these equations are giving the gravitational force. Same force we are getting on that mass m. So we can equate equation number 1 and equation number 2. Okay, by equating this we can write therefore mg is equal to capital G capital M small m divided by capital R square. Then we can cancel out small m on both the sides and therefore we will get small g is equal to capital G capital M upon capital R square. This is nothing but a formula for acceleration due to gravity. So acceleration due to gravity will be given by gm upon r square, where capital G is the universal constant of gravitation, capital M is mass of the earth, and capital R is the radius of the earth. So here is what we get. Acceleration due to gravity G is equal to gm upon r square. Okay, and already these values are known to us. Capital G, that is a universal constant, we know the value. Then M, mass of the earth, is 6 into 10 to the power 24 kilograms. R, that is radius of the earth, is 6.4 into 10 to the power 6 meters. By putting all the constants, we will get therefore G is equal to 9.8 meter per second square. So on our earth, the acceleration due to gravity, that is the average value of G, is equal to 9.8 meter per second square. So this is something you have to remember. Okay. So how much is the average value of acceleration due to gravity on our earth? It is 9.8 meter per second square. Okay, so on our earth, the value of small g is 9.8 meter per second square. But what will happen if we are going on some other object? Let us say on the moon. On the moon, we will write the formula of G as capital G, mass of the moon divided by radius of the moon. And definitely these values will be different for the moon. So we will get the value of G to be different. In fact, on the moon, the value of small g is 1/6 that of the earth. Okay, and if you go on any other planet, the value of acceleration due to gravity will change. Okay, generally planets like Jupiter or Saturn, which are having a very large mass, okay, there the value of acceleration due to gravity is much higher. Okay, on smaller planets, okay, there for example Mercury, right, the value of acceleration due to gravity is much smaller, right. So on different kind of objects, the value of acceleration due to gravity will be different. For our earth, the value of G is 9.8 meter per second square. Now another thing to remember, this value of G will be the same for all the objects. Means whether we have a very heavy object or we have a very light object, the value of small g will not change. It will be the same for all the objects. What it means is that if we are having two objects with us and we leave those objects so that they will fall down. Okay, if one of them is heavy and the other is light, both will have the same value of g, right? And because they are having the same value of g, that is acceleration, they will accelerate with the same rate. So they will have the same velocities. By the time they reach down, they will reach at the same time. Okay. So sometimes this question is asked that if you have a heavy object and a light object, let us say a 10 kilogram ball and a 1 kilogram ball, and you let go, which will fall down first? The answer is a 10 kilogram ball and 1 kilogram ball. Both will fall down at the exact same time because the value of acceleration due to gravity is same for both of them. An experiment like this was actually conducted by Galileo. I'm sure you must have heard this name. Galileo, he was a great Italian scientist. Okay, he is known for inventing the telescope. So Galileo conducted the experiment from the Leaning Tower of Pisa. Okay, in Italy there is a tower that is bent like this. It is called as a Leaning Tower. So from that tower he dropped two balls. One was very heavy, one was very light. And we saw that both the balls came down at the exact same time. So that is the concept of acceleration due to gravity. Now our earth, it does not have a perfect spherical shape. Correct, we know that along the equator it is elongated, along the poles it is bent. So it is more like this. Okay, it is not a perfect sphere. So because of that, the value of acceleration due to gravity keeps changing from point to point on the earth. Okay, so what happens is on the poles the value of acceleration is little bit higher, and along the equator the value is little bit lower. Okay, but on an average we take the value as 9.8 meter per second square. So that was the concept of acceleration due to gravity. Okay, I hope it was understood. Remember that this concept, that is acceleration, this concept is controlling all of us. So on the earth, the force of gravitation you can find out by simply taking F is equal to mg, mass of the object multiplied by the value of g. So if you want to find out what is the force of gravitation on you, all you do is take your mass, okay, whatever is your mass, let us say 40 kg, 50 kg, and multiply that by 9.8. You will get the gravitational force being exerted on you. Okay, so that's all for today. Go through the textbook, okay, read that topic from the textbook as well. In the next class, we will see how we can write the kinematic equations using this acceleration due to gravity. Okay, thank you.